Okay, so in case you were absent, this video is on the derivatives of inverses. Hopefully it'll be really short and it'll be easy and you'll be like, Miss B, this is easy. Okay, so that's a hope anyway. So real quick to review, what an inverse is if I am technically giving you the y value and you're going to find the x. And it's just a real simple way of saying that. So like if I say f of x equals x squared, what's f inverse of 9? That's the equivalent of me telling you what f of x is. It's 9. What are the corresponding x values? And you get plus or minus 3. Okay, and so you'd say f inverse of 9 equals plus or minus 3. This is what we say is not one-to-one. One-to-one means that any input into the inverse only gives you one value on the output. And so this just isn't one-to-one, but that's not a big deal. Okay, so likewise, if f of x equals x cubed plus 1, what's f inverse of 28? So you'd set 28 equal to x cubed plus 1, and x would be 3. So f inverse of 28 is 3. It swaps the x and y. Okay, I give you the output, and you tell me what the corresponding input would have been. Likewise, this is great because we're about to head into natural logs. What's f inverse of 1? So 1 equals natural log of x. Remember, this is log base e of x equals 1, so change that to an exponential e to the 1 would equal x. So f inverse of 1 equals e. Okay, so just keep that in mind. So let's talk about the derivative. So just like we set up the derivative of arctan and arcsine, etc., we're going to do the derivative of f inverse. So set it equal to something that we know. Y equals f inverse of x, and then change that using inverse notation. X equals f of y. Now we're going to take the derivative with respect to x. So you get 1 equals f prime of y, excuse me, and by the chain rule times y prime. Remember, y prime is what we're solving for. Y prime equals 1 over f prime, which is our original function, not its inverse, of y. And it's cool to derive this because then you understand that this truly is, I'm giving you the y value, okay? But you'll often see it written as our derivative, just rewriting the beginning. We know that y is an arbitrary variable that we made. It's actually f inverse. So the derivative of f inverse is 1 over f prime of f inverse of x. Okay, so you find the inverse value and you plug it into the derivative of the original function, and it's the reciprocal of that. So let's do an example, shall we? In this case, this is the easiest case to start with. We're given a function, and we're given the value of an inverse at a particular point. And it says find the derivative here, okay? So the function is f of x equals cosine x minus 6x, and f inverse of negative 9 pi is 3 pi over 2. So when x was 3 pi over 2, then the y value was negative 9 pi, which is cool, you know? Anyway, find the derivative of f inverse of x. So we're going to find the derivative of f inverse. How you write that in Leibnizian notation is you're saying find the derivative, then I'm going to evaluate it for x equals negative 9 pi. You don't want to say you're taking the derivative of f inverse of negative 9 pi because that's just a number and you'd get 0. So anyway, it's 1 over f prime of f inverse of negative 9 pi. Well, f inverse of negative 9 pi is 3 pi over 2. So I have 1 of f over f prime of 3 pi over 2. Well, alas, we just find our derivative. F of x equals cosine x minus 6x. F prime of x equals negative sine x minus 6. Evaluate that at 3 pi over 2. Remember, 3 pi over 2 is down here at the bottom on our unit circle. We're looking for signs. 0, negative 1. It's the negative 1. So be negative of negative 1 minus 6. 1 minus 6 is negative 5. So it's negative 1 over 5. Okay. All right, next one. If f of x equals x squared, find the derivative of the inverse. of f at x equals 4. And notice in this case, we are not given what the value of f inverse of 4 is, but we know we're going to need it. Okay, so I'm going to start by saying I need the derivative of f inverse of x evaluated at 4, which is 1 over the derivative of f inverse of 4. So clearly we're going to need the inverse of 4. So we're going to set 4 equal to x squared. And we get 2 possible x values, because this is not a one-to-one function. Okay, so f inverse of x, or sorry, 4, equals 2 possible values. So you can simply split it up and see what you get. We're going to have 1 over f prime. This is the case. What if x is 2? So 1 over f prime of 2. Oh, I'm sorry. When the inverse is 2. And then what if it's negative 2? Either way, we need our derivative, which is coming from this sucker right there. It's just 2x. So f prime of positive 2 is just 4. F prime of negative 2 is negative 4. We get 1/4, negative 1/4. Okay, and so essentially, our solutions are plus or minus 1/4. Those are the 2 possible slopes of the inverse. Okay, if you're really jonesing for another example, what about pretty much along the same lines? F of x equals cosine 3x and f inverse of 0 equals pi over 6. Find the derivative. Okay, so again, it's going to be 1 over f prime of f inverse of 0, because that's what we're evaluating it at. And f inverse of 0 is pi over 6, so it's f prime of pi over 6. And so that means we're going to know what f prime is. So f prime of x, use your chain rule here. It'd be negative sine of 3x, and then times the derivative of 3x, which is just 3. So evaluate that at pi over 6. Negative sine, 3 times pi over 6 is pi over 2 times 3. So pi over 2 is up here, and its value is 0, 1, and we're looking for the sign, which is 1. So negative 1 times 3 is negative 3. And the last, this leaves us with negative 1 over 3. Okay, they're almost always set up similar to this. You only have to think about, am I given the inverse? Am I not given the inverse? Okay, let's do this lovely one as our last example of this type. If f of x equals 3x cubed minus 4, find the derivative of the inverse when x equals 20. Okay, so we're going to do 1 over f prime of f inverse of 20. Okay, oh my gosh, what's f inverse of 20? Well, we're going to have to say 20 equals 3x cubed minus 4. Add 4 over and divide by 3. 8 equals x cubed. This is a one-to-one function. You're going to get x equals 2. So that's your inverse. F inverse of 20 equals 2. 1 over f prime of 2. Oh, so we'll have to find f prime of x is 9x squared. Okay, so f prime of 2 is 36. So it's 1 over 36. Beautiful. Okay, let's try out a portion of this AP problem. Okay, so in this case, we're given a table of values. Our x's, our inputs are 1, 2, 3, and 4. We have f prime, g, and g prime. We're not going to use f. Those were set up for a different problem. But you'll see on your assignment, there's some stuff about f on there, and that's okay. But what we're going to use is g and g prime. And if you have g, you can get g inverse as long as you're given enough values. All right, so it says if g inverse is the inverse function of g, write an equation for the line tangent to the graph of y equals g inverse at x equals 2. Okay, so let's think about this. We need a point, and we need the slope. Okay, so we need a point and a slope. So let's start with a point. We're saying I'm going to input 2. Now, this is our inverse, right? So what is g inverse of 2? And I'll go right there. Okay, so you're going to go backwards if I have the g function. I'm looking for g where the output was 2. What gave That should be a highlighter. What gave me that, what input value gave me an output of 2? Okay, remember that's the whole purpose of that inverse function. All right, and so that should be at 1. So g inverse of 2 is 1. That's going to give us that point, 2 comma 1. Okay, and we need it for our tangent line. So now we need our slope. So to evaluate the derivative there, okay, so the derivative with respect to x of g inverse of x, when x equals 2, will be 1 over g prime of g inverse of 2. And as you do more of these tables, you'll start to know, once you find what line you're at, you stay at that line, which is kind of neat. G inverse of 2 is 1, so you're at 1 over g prime of 1. So like I said, now I'm going to find g prime of that value, which would be 5. So your slope is 1/5. Now I've got a point and I've got a slope. It's y minus 1 equals 1/5 times x minus 2. Ta-da! Now this may seem pretty simple, but a lot of times, you have so many rules to remember, you forget this general rule. So a lot of people tend to miss these. So just be very careful. You can always rederive it if you need to. It was pretty simple to derive, basic implicit differentiation. And just make sure you finish your work. There's some good practice problems, and it shouldn't take you too long.